back and review it as well. So this will be on Canvas later on. So we are recording it now. So if you guys went through and watched that video that I put on Canvas on Monday afternoon, you had yesterday to take a look at that. Bob Moffitt on there was showing you how to do oxyacetylene welding. And last week we did oxyacetylene brazing. Well, today we're going to talk about the difference between oxyacetylene brazing and oxyacetylene welding. And I'm going to talk about a couple things that I'm not 100% sure Bob did really well in that video. I'm going to try to give you a little bit better. I'll share some of my experiences that I've had that seem to work a little bit better. One thing I did forget was to turn our tanks on. So I'm just turning the gas on right now. So when we are going to be welding, it's going to be very similar to brazing, but there's a couple obvious differences, and I'm going to be showing you that here in just a minute. Sammy, good morning. Thanks for making it on. First things first, I have a worksheet for this demonstration for you guys. If we go to, I'm going to just share my screen really quick so you guys can see where you need to go. Okay, can you guys see my screen right now? Somebody give me a thumbs up or a yes. I want to make sure you can see this.
Yeah.
Okay, good. So if we go back to our Canvas and we look in Canvas, we're going to go down to week 7. I didn't add another week there, so this is actually week 7 and 8. We had the oxyacetylene worksheet. We had oxyacetylene cutting. Oh, shoot, I didn't put that one in there. Darn it, why didn't that show up? I'm missing the worksheet. I'm going to put that in right now really quick for you guys. I'm just trying to think where I can put it. Nope, here it is. I just didn't have it published. There we go. So you guys should be able to see this oxyacetylene welding demonstration. It's going to pop up on yours right now because I just published it. I didn't have it published. So oxyacetylene welding demonstration, if you go in there, this is blank right now. I'm going to put the recording of this video in here. Here's your worksheet right there. So you guys can go through that worksheet right now and answer the questions as I go through there, or you can go back and review this demonstration and answer those questions later on. It's kind of up to you. But it's under oxyacetylene demonstration, and it's under week 8. Okay? So let's start talking about our oxyacetylene welding versus brazing and the weld.com video that we looked at the other day. So when he was showing you the oxyacetylene welding, we talked a little bit about this with brazing. He said one of the main things you needed to do was we needed to get our metal really cleaned off. And he actually took a grinder and ground everything on his metal till he had just raw bare metal. I took my sample piece of metal that I have today and I wire wheeled it to try to get it pretty clean, but there's still a little bit of mill scale on here. I probably could have cleaned it a little bit better. But the key point, when we're welding, we're going to turn our metal into a liquid pool. And because of that, you can't have any mill scale or any rust or anything like that on your metal. If you watched that video, you saw he had sparks coming off of his metal. That's because there was mill scale, there was garbage on the top of that metal. You got to make sure you clean that off. If you don't clean it off, it's going to pop at you. You're going to have all kinds of issues that are going to go on. So make sure you clean your metal up. We talked about that a lot when we were talking about arc welding and with wire feed welding. It's not quite as important with brazing, but it's very important when we're oxyacetylene welding. So keep that in mind if you guys are going to come in on Friday. Also a note on that, I did put the open lab sign up for this Friday on that week 8 as well. So you can go to the open lab and sign up if you want to come in and do this on Friday. Okay, so welding versus brazing. Who came in and did brazing this last week? Riley, you came in, but you were doing arc welding, weren't you? Riley, you didn't braze last week, did you? Or did you give that a chance?
I did cutting when I just did the little piece that was sticking out.
Okay, so you just did the cutting. You didn't do the welding or the brazing.
And then I just welded normally.
Okay, all right, that's fine. So some of your classmates would have been from third hour then did some brazing. Riley came in and did some cutting. But the big thing we have to recognize when we're the difference between brazing and welding. When we're brazing, remember we talked about brazing last week, we said that it's a lot like soldering. We were going to get our metal. How hot did we get our metal when I gave the demonstration? Remember when I did that demonstration? How hot did I get the metal? Parker, do you remember how hot I got that? Was it?
No.
Was it liquid?
Oh, red hot, red hot.
It was just red hot, right? Yeah. Mm-hmm. So we didn't get our metal liquid when we're brazing. We just got our metal red hot. That's all the hotter we needed it. Once your metal's red hot, then we add this brazing rod in, and the brazing rod kind of works through capillary action and it adheres to the metal. We didn't actually melt the base metal. We never got our metal, the base metal never really melted. It never became a liquid state. So that's where the big difference comes in with welding. Now that we're going to weld, we're actually going to melt the base metal. This base metal is going to turn into a liquid pool, and you're going to see that right now. And we're going to develop this liquid pool, and we're going to push the puddle along. And then we'll, as we're making a liquid pool on here, we're going to add filler rod to it. We'll talk about the filler rod in a little bit. First, we're going to do one without filler rod, and then I'll show you how to do one with filler rod. So that's the big difference between brazing and welding. Brazing is about 800 degrees. The metal's red hot. We never melt it. Welding, we're actually melting the metal. We're going to make it a liquid pool. We're going to push the liquid pool along. We're actually running about 3,000 to 3,500 degrees depending on our material. Okay? So knowing that we're going to be welding that hot, we have to have the same safety gear on that we had before. So I'm going to grab a jacket. I've got green jacket that we were wearing before when we were welding. Other items that are going to be the same as when we were welding. When we were brazing, we said we were going to use a number 5 face shield. It's going to be the same exact thing. So I've got my number 5 face shield ready to go. You'll recall last week when I was brazing, I did not wear any gloves. And you really don't, I mean, you can wear gloves if you want. It's probably a good practice. You probably should do it. But our metal isn't as hot. We're not dealing with as much extreme heat. Now that we're going to weld, we are dealing with a lot more heat. So I am going to wear some gloves. However, the gloves are a little bit different. When you guys were arc welding and when we were wire feed welding, we wore these big, heavy, thick leather gloves. They're pretty bulky. They kind of get in the way. Well, I've got some different welding gloves here, and these are actually TIG welding gloves. They're a lot finer. They're much softer, much more subtle, so I can move my fingers around a lot more. They offer protection against the heat. They'll offer protection in case there's a pop and I get sparks, but they're not as bulky as those big arc welding gloves. So we still want to make sure we have the right safety equipment, and we're going to proceed ahead, once we're all dressed up and ready to go. Okay, so I have right here 1/8 inch mild steel. I'm going to go ahead and we're going to try to start, we're going to weld on this. One of the things in the weld.com video that he did not talk about, I was a little disappointed that he didn't do it. When you're going to start welding on this, the size of your torch tip matters. In the weld.com video, he just said, hey, we're just going to use a number 2 tip and we're just going to go. The metal he was welding on, I will say that a number 2 tip wasn't nearly big enough. We have multiple different size welding tips. If we look at it, this one right here tells me that this is a 205. You guys won't be able to see that, but right here it has the size of the tip on there. That's an 05 tip. This is a 01 tip. The bigger the number on there, the bigger the orifice in the end of the torch, the bigger the orifice, the bigger the flame. The smaller the number, the smaller the orifice, the smaller the hole, the smaller the flame. Why would I want a bigger flame or a smaller flame? What do you think? What would the purpose be between having a bigger flame or a smaller flame? Cole, what do you think? Why would I want a big flame instead of a small flame?
Because they melt the metal different.
Sure. Well, let me ask you this. Which one do you think will be hotter, a big flame or a small flame?
Probably a big flame.
Probably a big flame, right? So yeah, if I have a bigger torch tip with a bigger number, it's going to give me a bigger flame. The bigger flame is going to produce more heat. Well, where do you think I'm going to need more heat? Thin metal or thick metal? Sammy, what do you think? Big metal or thin metal will need more heat?
Big metal.
Big metal, right? Yeah. So if we're welding thicker metal, I need to put on a bigger torch tip. Likewise, if I'm welding thinner metal, this is pretty thin metal, I can use a smaller torch tip. So thin metal, small torch tip, thick metal, big torch tip. The thickness of your metal is ultimately going to determine how big of a torch tip you need on there. If you just willy-nilly grab a torch tip and go, it may not work. And that was what I was observing in the weld.com video. Was he had a number 2 tip and he was welding 3/16 thick metal, which is pretty thick metal. Actually, 5/16 metal actually. And he had his torch cranked up way too high. So that's why he was struggling so much in the video, was he didn't have the right torch tip. Making sure you have the right torch tip will make or break you in this setup. So I've already got my gas set. We set the gas the exact same way we set it when we were brazing. So that shouldn't matter. And now that I just looked at my torch tip, I see it's a number 1. I kind of think I might need a number 3 for this. So I'm just looking to see if I have a number 3 here. That's a number 5 as well. If not, I'll just try the number 1 and we'll see if it works. These are all number 5. So we'll go ahead and just see how this works. So I'm going to light the torch the exact same way I did before. I want to get this set up so you guys can see my metal. Somebody's going to have to give me some feedback here. Okay. Can you guys see that piece of metal okay? Somebody tell me if you can see that or not.
Yeah, we
We can see it.
Okay, good, because that's what we're going to demonstrate on. So when I go to light the torch, we're going to light the torch the exact same way we did before. We're going to turn on our fuel first, turn on the acetylene. And we want to go from having a dirty, sooty flame to having a nice dancing flame. And then we're going to turn on the oxygen. Turn on my oxygen. And we can see that our flame gets nice and clean right here, nice and neutral. I got to turn the fans on really quick. Okay, so last week we talked a little bit, and they talked about it in the video. We have 3 different flames. We have a carburizing flame. Neutral flame is right when that feather disappears into a round cone. That's what we refer to as the cone right there. We talked about the cone last week. We said we want to hold that cone how far off the metal. Who remembers how far we hold that off the metal? Jackson, do you remember how close I held that to the metal last week? Jackson, you there? No, Jackson. Okay. That works. Jackson said he didn't remember, which that's fine. So when I'm welding, I want to hold that cone about 1/4 of an inch off my metal. I don't want it touching the metal, but I want it right next to the metal. But here, the reason I'm talking about that is because that cone, when we're setting our flame, we have to set that flame so we have a nice steady cone. If you watching that video with Bob Moffett, he had a flame. He cranked that thing up. I don't even know if I can turn it up as high as he had it. He had it cranked up and that torch was just screaming. What I'll tell you is when we set up our torch, you want your torch to be nice and quiet. It shouldn't sound like a jet taking off. I'm going to turn this down just a hair. Oh, it's not going to let me. So right now, can you guys hear this torch? Can any of you guys hear it from where you're at right now? I can't see it because I've got that down. Okay, so Jackson says, no, we can't hear. If you're right here with me right now, you can barely hear this torch kind of whistling a little bit. If we crank this thing up, way up really high, it's going to sound like an F-14 jet taking off. It's going to be going. Your torch should not sound like a jet. It should not be making a jet sound. It should be relatively quiet or making just a little bit of sound. If it's making that jet sound, you have way too much gas turned on. You need to turn it down. So, and the other part of that is your cone is not going to be nice and condensed if you've got it cranked way up. So right now we've got a nice rounded cone and we're going to be able to work with that. So I'm going to hold the torch just like I did last week. I'm going to hold it just like a pencil. And we're going to hold that cone just barely off the metal, about 1/4 inch. So I want that cone right about here. I don't want the cone down on the metal like this. Likewise, I don't want the cone up in the air like that. If you hold it up in the air, it's going to spark and spatter at you and it overheats your metal and a lot of bad things happen. So trying to see my picture here. You guys see that okay, right where the torch is coming down? Somebody give me a yes or no.
Yeah.
Okay, good. So I'm going to hold the torch just like a pencil. I'm going to angle it ahead, and then I'm going to get our metal liquid. And I'm hoping you guys are going to be able to see this. The brazing I knew you could see, but I'm not 100% sure if you'll be able to see the weld. But we want to try to get a puddle that's about the size of my pinky nail, my pinky fingernail. If it's much bigger than the pinky fingernail, you're probably too big of a puddle. It might be a little bit smaller than a pinky nail, but right in that ballpark. That's kind of what we're looking for. So here we go. I'm going to bring the torch down. I'm going to angle it ahead, and I'm going to do an up and down oval just like I did with my brazing. But now I'm going to wait until I have a liquid puddle. Okay, somebody turn their mic on and tell me, can you guys see that liquid puddle, or is it just a bright blur?
Bright blur.
Yeah, that's what I was afraid of. So the welding is a lot like, it's a lot more like arc welding in that it's really bright. It's definitely brighter than brazing. So I wasn't sure if that would show up on the camera or not. But I'm going to run this stringer bead ahead here, and then I'll show you guys what it looks like. So what I'm doing right now is I'm pushing this puddle, and I'm going, so I go up and down, and I've got a liquid puddle in front of me. And notice, I'm not going really fast, am I? The other big difference is, if you guys that watch that video, weld.com video, do I have all kinds of sparks blowing off here like that guy did? No, there's no sparks. It shouldn't be sparking. It shouldn't be blowing stuff all over the place like he had going on. It should be a nice, smooth, easy weld, and we should be able to just terminate it. So then when we get done, I can, again, just shut off my fuel, shut off my oxygen, set my torch down. Okay, what's the first thing I did with my metal as soon as I'm done welding on it? What's the first thing I do? Cordy, what's the first thing we do with our metal? What do we do?
You cool it off.
Cool it off. That's right. First thing we do, dunk your metal, cool it off. So, let me grab a brush here really quick. Where's my brush? Here. All right, so what you're going to see here now so if you guys take a look at this, get it up here where you can see it. Notice how right here on the weld, it's actually got indentations on the weld. Or on the metal. The base metal actually it's indented a little bit. I've got some little U-shaped rings in it right there. I can see that my puddle was actually penetrating into that base metal. Notice the size of my weld when I look at it. It's about the size of my pinky nail. So that's what we're looking for. Ideally, our weld should be twice the width of the thickness of our metal. Well, that's about twice the width, probably a little bit more than twice the width of the thickness of the metal. It's got these nice U-shaped rings in it right here. It's indenting. When I feel it, I can feel it's indented down into the base metal. So that's the key part there is we melted this base metal and we actually were swirling it around in there a little bit. The other thing you're going to notice is I don't have that scale all over the place that he had in his other video from Tuesday. And that's partly because I refer to it as cooking your metal. If you get the metal too hot, you're actually going to draw some of the carbon out of it, which is what he was doing. And you'll get scale all over the place, and that's when it starts sparking on you. Okay? All right, questions so far? Questions so far on welding? You guys have that worksheet up. Sammy and Jackson, you guys came in a little bit late. If you go look at week 8 on the oxyacetylene, you're going to see the demonstration module I put on there. There's a worksheet for this video that is on there. So you guys can jump in there and open up that worksheet if you want right now. Okay, so let's start talking about filler rod if you guys don't have any questions. When I'm adding filler rod, you guys will remember when I was brazing, we used a brazing filler rod. We used brass on steel because the brass melted at a lower temperature. This was melting at about 800 degrees. And it allowed me to combine dissimilar materials. But now that I'm welding, my base metal is going to be liquid. The only material I can add is the same material as my base metal. So I have mild steel base metal. That means I need a mild steel filler rod. This is a mild steel filler rod. So if you take a look at the filler rod, it looks like it's copper, right? Well, it actually has a copper coating on it, but it's a really, really fine copper coating to keep it from rusting. That way the metal doesn't, my base steel doesn't rust. So I do have a fine copper coating on it, but it is mild steel. We have different size filler rods, just like we have different size welding rods. And I don't know if you guys can see that because they're pretty fine, but this is a 1/16 of an inch filler rod. This is a 3/32. This one is thicker. We use heavier filler rod for thicker metal, thinner filler rod for thin metal. This is pretty thin right here, so I would recommend we go with a smaller filler rod. Okay? Here's where most people get into trouble, and I watched Bob do this on the video. When you're adding filler rod to our base metal right here. So when I'm adding filler rod into this base metal, the filler rod will not join into the base metal unless that base metal is in a liquid state. I have to have a liquid puddle here in order to add the filler rod into it. Most new welders will start welding, they get a little puddle going, and then they try to melt the filler rod. And they're taking the torch and they're trying to melt the filler rod with the torch. The torch does not melt the filler rod. The puddle is what melts the filler rod. If you have a liquid puddle and you dip the filler rod into the liquid puddle, the puddle will melt the filler rod, not the torch. Everybody got that? And that's an important piece. Okay? You will know if you don't have enough heat, if your metal isn't hot enough, because when you go to add the filler rod, your filler rod's just going to stick. It'll stick right on the base metal. And students do this all the time. They go to put their filler rod in, and it goes thunk, and it sticks to the metal. Then they go, and they start dragging their metal all over the place. If your rod is sticking to the metal, it's because you don't have a big enough puddle or your metal's not hot enough. Get your metal nice and hot. Your filler rod won't stick. You'll be able to dip it in there. The other part of this is you don't even need to dip it. You can just lay it there and then just push the puddle along. The puddle will suck the filler rod into it as we go. So let's try it out, see what it looks like. I was going to try, I don't know, that ain't going to work. I had this grandiose idea yesterday of maybe putting one of the welding helmets in front of the camera so you guys can see it, but I think you're just going to get glares from the light. So we'll try this out, and then I'll show you what it looks like as soon as I get done. So we're going to crank the torch up. We're going to add our oxygen. Get a nice neutral flame so we don't have a feather on there. Our cone is nice and rounded, but it's a quiet torch. Torch isn't jetting, it's nice and quiet. Okay, so here we go. Just trying to see, make sure you guys can see that okay, right? All right, so here we go. So I'm going to hold my torch just like I did before, and now I'm going to hold the filler rod in my left hand, but I'm not going to bring the filler rod down until I have a liquid puddle. And this is where it gets a little bit trickier because now your filler rod's just hanging out there, and I have a tendency to shake it all over the place. So this is where I just stick the filler rod down in the metal and just kind of push it in as we go. So you guys probably can't see that real well, but I have a liquid puddle starting here now. So I'm going to put my filler rod in. And as I go up and down, I'm adding the filler rod. Yeah, I'm shaking all over the place here. Let me try this again. So I go up and down, creating the puddle. And I just stick the filler rod right down on the leading edge of that puddle. I put the filler rod on the front end of that puddle. As soon as the puddle gets to the filler rod, the puddle melts the filler rod right into place. If I don't have a liquid puddle, then the filler rod's not going to melt. That's when it sticks. So it's kind of my telltale sign is, do I feel the filler rod being free? It's melting and it's free, or is it trying to stick onto the metal? Notice I got some more sparking this time than what I had last time. That's because I got a little bit of the carbon burnt out of the material last weld. But it didn't pop on me or anything, which is good. Okay. So, first thing we do, cool our metal off. Next thing we're going to do, wire brush it a little bit. And let's take a look at it. I'll try to pull this up a little bit, get a little better light on it. Okay, so can you guys see that weld right there okay? Or not? I can try to put more light on it if you can't see it.
Yep.
Okay, so we can see right here, this was the first weld I did. That one just sunk down into the metal. It really, as a weld, it's not doing anything. When I added my extra filler rod right here, you can see still about the size of my pinky nail, still have those nice U-shaped rings in it that we're looking for, but now it's mounted out of my base metal. I actually have extra material in there. So if this was actually a joint and I was joining two pieces of material together and that weld went over the top of it, the fact that it's mounted up and built up right there means that that weld would actually be stronger than the base metal. And that's what we're looking for. We talked about that a little bit with arc welding and wire feed welding, but that buildup is what is going to make our weld stronger. So we should see it mounted up a little bit. We don't want it globbed up, sitting in little balls. We want it to be nice and smooth. It should have those nice U-shaped rings in it. That tells us we've got a nice steady weld on there. I will tell you that if you can do this right here, what I just did, jumping ahead to TIG welding, which is what we do in metals too, is actually quite easy. I have got a lot of students in metals too that say, oh my gosh, I'm worried about the TIG welder. I don't think I'm going to be able to TIG weld. And then I ask them if they did oxyacetylene welding in 9th grade or in Metals 1. And they say, well, yeah, that wasn't that bad. TIG welding is the exact same way. And that's something that we do in our Metals 2 class. So that is oxyacetylene welding with and without filler rod. Big difference between oxyacetylene welding and brazing is what? What was the difference? Jace, what was the difference between the welding and the brazing?
In welding, you actually join the metals together.
Yeah, we actually made a pool, right? And we added that extra metal in there. Yeah. And then brazing, how hot did we get the metal? Riley, how hot was the metal in brazing? Riley, you there?
Like,
How hot did I get the metal when I was brazing last week?
I don't remember.
Who remembers how hot we got the metal last week? We said at the beginning of this demonstration, remember the metal only got
Red hot.
red hot, yes. So we only got our metal red hot last week. This week, we actually melt the metal into a liquid pool. So that's the biggest difference. The other big difference with brazing, we can join dissimilar materials. So I could braze stainless steel to mild steel. With welding, we can only connect the same material. We can't connect dissimilar material. Okay? All right, so I'm going to actually stop this recording right now. Any questions on welding from you guys? Anybody have any questions on